Hello there, welcome to A2 Maths. We're on Specimen Paper 1, and here we're looking at question 1, a trapezium rule question. So we have the graph of y equals x over 1 plus the square root of x. The finite region R, which is shaded in figure 1, that will be on your test paper, is bounded by the curve with the equation x equals 1, the x-axis, and the line x equals 3. The table shows corresponding values of x and y for y equals x over 1 plus the square root of x. Use the trapezium rule with all the values of y in the table to find an estimate for the area R, giving your answer to 3 decimal places. So let me just remind us what the trapezium rule formula is. The area is going to be equal to 1/2 times h times by, and in brackets, y0 plus yn, that's the last y value, plus 2 lots of y1 and all the y values in between, so all the way up to yn minus 1. That's the formula in the formula booklet. Make sure you know it's there and when you need to use it. Now h is referring to the value of the difference in the x coordinate, so it's going to be 1/2 times 0.5 times by, now the last y value is 0.5, so the first y value is 0.5, the last y value is 1.0981, and then we add 2 lots of all of the intermediate y values, so that's 0.6742 plus 0.8284 plus 0.9686, close bracket again. Grab your calculator and you should get an answer of, let's just type it in quickly, and we get 1.635, that's to 3 decimal places. Okay, great, so there we are, that's the answer to question 1a. If you need a video, if you need some help in how the trapezium rule works, there's definitely a video for you. But when you're using the trapezium rule just in the case of an exam question, you don't really need to know how it works, just to quickly apply it. It's only 3 marks, get it done and out of the way, moving on to the next parts of the question. Part B, explain how the trapezium rule could be used to give a better approximation of your value for R. Well, you could have a smaller h value, smaller widths between the bars. Smaller widths between the bars. Okay, so there we are, that's the answer to part B. And part C, given your answer to 3 decimal places, let me just remind us what our answer was. Our answer was 1.635 to part A. Use your answer to calculate and deduce an estimate for this first expression here. Well, the only difference between this expression here and the one that we've found the area of is that there is a 5 on the top. Now what we can do when there's a 5 scale factor multiplier is just kind of like pull it out to the front. So I is going to be equivalent to this expression here, where it's just 5 times by 1.635. So grab your calculator, 5 times 1.635, that gives you 8.175. So that's your answer to part I. The answer to part II, now what you can do with integrals as well is you can split them up into 2 separate integrals when there is just an addition in between them. You can't do it for multiplication, you can do it for subtraction, you can't do it for division, but what you can do it for is addition and subtraction. So we can split it up into 2 separate integrals. We know that the integral of this one here, that's 1.635. The value for this one here is going to be 6x in between the boundary of 3 and 1, so that's going to be 18 minus 6 plus 1.635, and then we get an answer of 13.625. You could also approach this question from a geometric point of view. When you add 6 onto an equation, you effectively move the graph up by 6, and that will create basically a rectangle of height 6 in between the distance from 1 to 3. So effectively you've created another area of a rectangle of 12, 6 by 2 that is, So therefore that you'll add basically 12 onto your 1.635, which is exactly the same answer as what we'll have got here. So there we are, that's the answer to question 1, a little bit of trapezium rule there, and a nice couple of questions at the end there, testing your understanding of integration. You can pull out a scale factor multiplier, and you can also split things up if you're adding two functions that need to be integrated. So there we are, 6 marks for question 1. Let's now move on to question 2.